Hi students, welcome to my channel Thoughts of Physics.
In the video series of ray optics, in this class, I am going to explain lens maker's formula. So, to derive this lens maker's formula, let us consider a convex lens. Convex lens. So, what is convex lens means? A lens which is thicker at the middle, thinner at the edges. The convex lens. It is a converging lens. So, now let us consider a convex lens. This is the convex lens. Convex lens. It is thicker at the middle, thinner at the edges. The geometric center of the lens is called optic center. This is the geometric center of the lens, that is optic center. So this convex lens, we have two spherical surfaces. This is one spherical surface, this is another spherical surface. Now let us label the two spherical surfaces as A, B, C. ABC is one spherical surface. ADC is another spherical surface. We label the two spherical surfaces as ABC, ADC. Let us draw the principal axis passing through the optic center. This is the principal axis. Principal axis passing through the optic center. This is the optic center, the principal axis. Now let us consider an object is placed on the principal axis. An object is placed on the principal axis. This is the object. Let us say O. O is the object. So to get the image of this object, we can use two light rays, any two light rays. Let us consider a light ray from this object, incident on the convex lens like this. This is the light ray incident on the convex lens. So when the light ray incident on the convex lens, it undergoes refraction at the first surface, ABC surface. It undergoes refraction, it changes its path. It undergoes refraction like this. And the light ray undergoes refraction at ADC surface also. It changes its path. Finally, it touches the principal axis somewhere here. This is the light ray. Now, so second light ray passing along the principal axis, I consider this. The two light rays meet at particular point. There it forms the image. Now let us consider this is the image form. So this is the object. For this object, the image formed at, let us say, I. The image formed at I. The object is O, image is formed at I. That is the image. Actually, this process, the formation of image process, which takes place in two steps. What are the two steps means? The first step, the refraction takes place at ABC surface. And in the second step, the refraction takes place at ADC surface. So let us discuss the two steps separately. Now let us draw ABC surface and ADC surface. Let us discuss the phenomena what happened. Now for example, let us consider here, let us define the distances. Now this is the optic center. So this distance is called object distance U, and from the optic center to image, the distance is called image distance V. Now let us discuss the two steps what are involving in this process. Now let us consider this it is equivalent to this process. Total whole process is equivalent to. Now first let us consider ABC surface. This is ABC surface. So A, B, C, ABC surface. Now let us draw the principal axis. This is the principal axis, and so now ABC surface we have taken the principal axis. Next one is here, as usual, here object is placed at O. Now then similarly let us place the object at O. This is the object O. At O the object is placed, point object is placed at O. Then next, a light ray from this object, a light ray incident on the ABC surface. Light ray incident on the ABC surface. Now When the light ray incident on the ABC surface, it undergoes refraction. ABC surface acts as a convex surface. A convex surface, so it acts as convex. Light ray converge. Now, whenever the light ray incident on this ABC surface, it undergoes refraction. Let us consider this is the center of curvature of the ABC surface. C1 is the center of curvature of the ABC surface, and this BC1 can be taken as R1, that is radius of curvature of the ABC surface. Radius of curvature of the ABC surface. Now, if you want to draw the normal, that means you have to join the point and the center of curvature. That gives the normal to the spherical surface at any point. So now here, if I want to draw the normal means, now, so if you join the point and the center of curvature C, that is the normal. This point is, let us say this is A, B, C. Now already we know that the angle between incident ray and normal is called angle of incidence. That is, this is the angle of incidence. That let us say it is I1. Now, once the light ray incident on this ABC surface, it undergoes refraction. Okay, it undergoes refraction and it forms the image like this. Refractor ray, it touches the principal axis somewhere here, and it forms the image at that particular point. Now this is the image. Let us say this is I1. At I1, the image is formed due to the ABC surface. The image is formed due to the ABC surface. What is I1 means? I1 is the image formed due to the ABC surface. I1 is the image is formed due to the ABC surface. Now, this is R1. That is, the angle between refractor ray and normal can be considered as angle of refraction. Then that is R1. I1 is angle of incidence. Angle of refraction is R1 for this ABC surface. Now we have taken the first step. What is the first step means? The image formed due to the ABC surface. That's the first step. The next one is, so here we have to consider one thing, that is, here the medium, the rarer medium here, the refractive index of this rarer medium is N1. And this is the lens medium. This is everything is taken place inside the lens, that is N2. The medium refractive index of the lens is N2. Now here, so if you observe that, this is the image formed due to the ABC surface. Now, the image formed due to this ABC surface, that is I1, it acts as virtual object for the ADC surface, second surface. The image formed due to the ABC surface, that is I1, it acts as the virtual object for the second surface, that is ADC surface. Now let us consider ADC surface also. Here this is the ADC surface. This is the ADC surface. Now A, D, C. ABC surface first surface, ADC surface is second surface. Let us draw the principal axis. Now I am drawing the principal axis, this one, and this is ADC surface. This is ADC surface, A, D, C, ADC surface. Now here what we are telling you now, whatever the image formed by this ABC surface, that is I1, it acts as the object for this second surface. For example, if ADC surface here it lies, let us consider. So lens means like that only. So ADC surface, if it lies like that, the image I1 due to the ABC here, this acts as the object for this ADC surface. For example, let us consider this I1 somewhere here. This is the I1. This I1. Here, this is, if it is ADC surface, this is I1. So this is ADC surface, this is I1. Now this I1 acts as virtual object for the second ADC surface. Now this I1 acts as the object for this ADC surface. Now, so whenever a light ray from this I1, let us consider this is the light ray from this object. From this I1. I1 means it acts as the object for ADC surface. For example, if you imagine ADC like this only. Now this is I1. From this is a light ray. Now, so for this light ray, it acts as a diverging surface. This is, for this light ray, it acts as converging surface. So for this light ray, it acts as diverging surface. That light ray here, it undergoes diverges. Now, so when it diverges, if you pull it back, finally it forms the image at particular point I. It forms the image at particular point I. Now let it be So now here actual image formed at I. The final image formed at I. This is actual process what is going on here. That is, for example, if you just taken this one as C2. C2 is the center of curvature of this ADC surface. Center of curvature of this ADC surface. This distance can be taken as R2. That is radius of curvature. Radius of curvature for this ADC surface. Now, if you want to draw normal, that means we have to join the center of curvature and the point. This is the normal. And this is the angle of incidence for the second surface, that is I2, and this is R2. So this is about the two-step process. This is the main diagram. Now this process, the process of getting image here, this involves two steps. The first one is refraction at ABC surface, and second one is refraction at ADC surface. So finally the object is at O and final image formed at I. Now the final image here, it formed at I. This is the I, the final image formed at I. This is the total process here. Now let us discuss here some derivation. So what is the derivation for that? Already we know the relation of refraction at spherical surface. The relation of refraction at spherical surface, that is N2 by V minus N1 by U is equal to N2 minus N1 by R. This is the relation of refraction at spherical surface. Actually, what is the meaning of this equation? Let us understand. Now here, V means image distance, U means object distance, R means radius of curvature. Here, how we have written this equation means, this is N2. N2 means the refractive index of the image space. Image space means the region where image is placed, image is formed. This is the image space. The refractive index of the image space by image distance. And this is refractive index of the object space by object distance. Now this is difference of the refractive index by radius of curvature. This is the actual relation. The refractive index of the image space by image distance, refractive index of the object space by object distance, and this is the difference of the refractive index by radius of curvature. Here minus we have taken according to sign convention. So before applying sign convention, it is plus only. So according to that, just let us write this relation for both the surfaces. But both the surfaces means for both the refraction phenomena. Right. Now let us apply by applying relation of refraction at spherical surface. Refraction at spherical surface. Refraction at spherical surface for the side ABC. For the what is this? Two spherical surfaces ABC and ADC. I am applying first for ABC surface. For the surface ABC. For first ABC surface, I am applying the what is this? This relation of refraction. Now, what is the relation means? Refractive index by its distance. That means first let us consider object. So in this object, this is the object for ABC surface. O is the object. In this region, the refractive index is N1. In this region, the refractive index is N1. That means N1 by object distance. So object distance here it is BO. Always the distances are measured from 4. That is optic center. That means here the optic center and B are very close to each other. We are neglecting the distance. So now BO is the object distance. N1 by BO. N1 by BO. This is refractive index of object space by object distance plus next refractive index of image space. For this ABC surface, image is formed at I1. Image is formed at I1. So that means in this image space, the refractive index is N2. In this image space, the refractive index is N2. That means N2 by image distance. Image distance can be taken as BI1. Image distance can be taken as BI1. So that is BI1. So the refractive index of image space by image distance. Image distance for the first ABC surface is image is formed at I1 due to this ABC surface. So image distance is BI1. I am taking BI1 is equal to the difference of the refractive index N2 minus N1. N2 minus N1 by over. Now radius of curvature for this spherical surface ABC. Radius of curvature is BC1. After that we will substitute the values BC1. So let it be equation number 1. Here you can observe that this is N1 rarer medium. This is completely lens. This is completely lens. That's refractive index is N2. Now here this is again N1. Again that is N1. That is also rarer medium. That is also refractive index. Both having same. In this one is lens medium. Now this is we have applied the refraction formula for the ABC surface. Similarly, applying relation of refraction. Applying relation of refraction at spherical surface. Okay, it's okay. Relation of refraction for the surface. For the surface, next surface, second surface is ADC surface. Now for ADC, I am applying the relation. Same. For this ADC surface object. So now image formed by this ABC, that is I1, it acts as virtual object for this ADC surface. For this ABC object is O. But for ADC object is I1 only. It acts as virtual object. So object distance for this becomes, what is that? DI1. DI1 is the object distance. DI1 is the object distance. So now let us consider object distance is DI1. In this, the refractive index of the medium is, let us say that is N2. That is object space refractive index is N2. N2 by object distance is DI1. Object distance is DI1 plus image. Due to this ADC surface, image is formed at I. Now in this region the refractive index is N1. So that's why N1 by image distance is DI. Image distance is DI. Final image formed due to ADC surface is I. That's why DI. Then what is that I1 means? Here whatever image formed due to ABC, here this I1, that I1 same. In the absence of this ADC, how it forms the image, that I have shown there. And that light ray get that is diverged and it final image formed at I. That is N1 by DI. That is equal to here N2 minus N1 by. Now the radius of curvature of this ADC surface is DC2. D2C2. That is DC2. Now just modify it. Now for this DI1 term, let us apply sign convention. DI1 only for this DI1. For remaining terms, let us apply later. For this DI1. So D to I1. DI1. DI1 means we are measuring from D to I1. This is the incident ray direction. So D to I1 means we are measuring in the opposite direction. So that's why this DI1 becomes minus. For remaining terms, let us apply later. Right. Now here see that DI1 can be taken as BI1. DI1, BI1 both are same. If the lens is thin lens, BI1, DI1 both are same. That means in place of this DI1 you can write BI1. So that means as DI1 is equal to BI1, DI1 is equal to BI1. That means you can write N2 by minus BI1. In place of DI1 I am writing BI1 plus N1 by DI is equal to, as it is I am writing this, N2 minus N1 by DC2. Let it be equation number 2. This is the first equation, this is the second equation. So let us add the two equations. Let us add the two equations. That is, by adding the two equations, what we will get, that is equation number 1 plus 2. By adding the two equations, left hand side, if you add the two equations, left hand side of the first equation, that is N1 by BO. N1 by BO plus N2 by BI1. This is the first equation left hand side. Plus that is added to second equation left hand side, that is N2 by BI1. Here see, this is minus BI1. Now I can write here it is directly minus BI1. N2 by BI1 plus N1 by
N1 by Ti, that is equal to,
if you are right hand side of the first equation is N2 minus N1 by BC1. Right hand side of the second equation is N2 minus N1 by DC2. That we are adding the two terms, that is N2 minus N1 by BC1. N2 minus N1 by BC1 plus N2 minus N1 by, this is DC2. We are adding the first equation and second equation. First equation and second equation both we are adding. Now here if you observe that this is N2 by BI1, N2 by BI1. Both this is positive and this is negative get cancelled. After cancellation of these two terms, we'll get N1 by BO. N1 by BO here. Plus N1 by DI. After cancelling the two terms, N1 by BO plus N1 by DI, as it is I have written, is equal to, so we left with here see N2 minus N1, N2 minus N1 common for these two terms. Now we can take N2 minus N1 common. If you take N2 minus N1 common, what we left with here? 1 by BC1 plus 1 by DC2. 1 by BC1 plus 1 by DC2. So let it be equation number 3. This is the first equation, second equation, that is the third equation. Equation number 3. Now let us take these values from the figure and let us substitute with the sign convention. Now BO. BO means this is from B to O, object. It is called object distance. Object distance denoted by U. It is measured from B to O in the opposite direction of incident light, that is taken as negative. That means BO is equal to minus U. So BO is equal to minus U. Next term, DI. DI means from D to I. I is the image. That is called image distance. That can be taken as DI, can be taken as V. So it is positive or negative means it is measured in the same direction of incident light. DI, direction of incident light also same. That's why it is positive only. Next term, what is the next terms we have? BC1 and DC2. So BC1 is equal to, so BC1 means BC1. So this is radius of curvature of the first ABC surface. So it is measured in the same direction of incident light, that can be taken as R1 plus R1. Next DC2. DC2 means the radius of curvature of the second surface, ADC surface, that can be taken as R2. It is measured see in the opposite direction of incident light, D to C2. That's why DC2 can be taken as minus R2. These are the values of what we need in this expression. Now let us substitute these values in the third equation. So from the third equation implies N1 by this is minus U. BO is minus U plus N1 by DI. DI is V. We have already known the value. That is equal to N2 minus N1. N2 minus N1 into BC1 value is R1. DC2 value is minus R2. Now we can write that one as 1 by R1 minus 1 by R2. So see, BC1 is R1 and DC2 is minus R2. So minus plus into minus 1 by R2 we got here. Now from these two terms, N1 we can take common. That means if you take common and we are arranging the terms, that we will get that N1 into I am writing positive first, 1 by V minus 1 by U. 1 by V minus 1 by U, that is equal to N2 minus N1. N2 minus N1 into 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. Now let us take the value of n1, okay, that side. Then 1 by v minus 1 by u. 1 by v minus 1 by u is equal to n2 minus n1 by n1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. So let it be 1 by v minus 1 by u is equal to, this can be written as n2 by n1 minus 1, because n1 by n1 it gives 1, into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. Now 1 by v minus 1 by u is equal to, this can be written as n21, refractive index of the second medium with respect to first medium, minus 1 into 1 by r1 minus 1 by r2. Let it be equation number 4. Next, so let us consider if the object is at infinity. If the object at infinity, the light ray are parallel to the principal axis. Whenever the light rays are coming from infinity means these are parallel to principal axis. Whenever the light rays are parallel to principal axis, after refraction, it will passes through the principal focus. We know that. Whenever the light ray parallel to the principal axis, after refraction, it will pass through the principal focus. That means if object at the infinity, okay, then image formed at F, that is principal focus. At a principal focus, just write principal focus F. That means if object distance u is equal to infinity, if you take, that implies the image is formed at a principal focus. That means image distance will be F, focal length. So let us substitute these values in the equation number 4. That means from the fourth equation implies, that is 1 by, in place of this v, okay, that is F, focal length, minus 1 by object at infinity, 1 by infinity, that is equal to n21 minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. Now we know that 1 by infinity is 0. 1 by infinity is 0. That means that finally we will get 1 by f is equal to n21 minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. This is known as lens maker's formula. That is the reciprocal of the focal length, is 1 by f is equal to n21 minus 1. n21 means the refractive index of the second medium with respect to first medium. Here the refractive index of the lens medium with respect to air medium. So into 1 by r1 minus 1 by r2. 1 by r1, r1, r2 values are the radius of curvature, the radii of curvature of the two spherical surfaces of the convex lens. So this lens maker formula, it is used to design the lenses of desired focal length using the suitable radius of curvature of the surfaces. If you want to calculate the focal length, here if you know the radius of curvature means we can find the focal length. So to design the lenses of desired focal length using the suitable radius of curvature, this lens maker's formula is used. Lens maker's formula. So this formula is used to design the lenses. So now here one important point we have to observe, that here we got here in place of 1 by v minus 1 by u, finally we got 1 by f. By taking these assumptions, 1 by v minus 1 by u, we considered it as 1 by f. That means 1 by v minus 1 by u. In place of that we got 1 by f, that is 1 by v minus 1 by u, that is equal to 1 by f. This is known as, that is thin lens formula. Thin lens formula.
If you have any doubts, you can ask in the comment section. For latest updates, subscribe and click the bell icon. Thank you.